Good morning. This lesson is for my Honors Integrated 1 class, but before I get started, I want to say I hope that everyone's doing all right up there. I'm not sure how I'm going to title this, but I'm going to title it how I title in the title. But what I am sure of are two goals for the day. Our first goal is going to be to define and investigate absolute value. Our second goal is going to be to solve absolute value equations. Alright, so let's go ahead and jump right into our first goal. Let's define absolute value. Absolute value means the distance to zero. Alright, absolute value means the distance to zero. Think about it only as the distance to zero, and it'll make a little bit more sense. The symbol for absolute value is two vertical segments. So there's my two vertical segments, and this is the absolute value of x. Think of it like this. How far from zero is x? Again, it's a distance to zero. So I have a couple examples on the board. I have the absolute value of 3 and the absolute value of negative 3. If I say it like that, it doesn't mean much. But if I say what it means a little bit more. So I'm not going to say the absolute value of 3. I'm going to interpret what it means. How far from 0 is 3? Well, 3 is 3 units away from 0. So, now I'm going to say the absolute value of 3 is 3. But I'm trying to answer it, I'm going to think about it as a distance. Alright, the second example. I'm not going to think about this question as the absolute value of negative 3. I'm going to think about what it actually means. How far from 0 is negative 3? That's what that question is about. Well, negative 3 is 3 units away from 0. So, the absolute value of negative 3 is positive 3. Absolute value must be positive because it is a distance. This is a very important concept in this lesson. Absolute value must be positive because it is a distance. It can also be 0. Absolute value must be positive because absolute value is a distance. All right. Now, what this also does is this shows us that there are two numbers with the same absolute value. Alright, so it's very important. I have two different numbers on a number line that have the same distance from 0. So, if I'm talking about the absolute value of x is 5, that means what numbers are 5 away from 0? 5 units from 0. Right? And if you think about it again as distance, it makes a little bit more sense. And that means that hopefully that makes sense why x is 5 and negative 5. Because there's two numbers that have a distance of 5 from 0. Okay, so now that we know that there's two possibilities for absolute value outcomes, we can now go into the part of setting up equations. So here's how we're going to set up absolute value equations. What numbers are 5 units from 0? Well, there's two possible numbers. So what that means is we're going to split this up. So I know that I can have a distance that's 5 units away on the right side of 0 on the number line, and a distance that is 5 units away from the left side of the number line. Left side of 0 on the number line, sorry. So absolute value equations are going to split into two parts. We have the distance to the right of 0 and the distance to the left of 0. So I'm going to go ahead and check off the first goal, come back and show you how to solve absolute value equations. So let me clean this up, set up the next lesson, and I'll be back. I'm back, so let's go ahead and continue this lesson. I wrote down here the key step. And that's to split when the absolute value is isolated. Alright, so my absolute value in example 1 is isolated, so I can split this. So what this means is that there's two numbers that have a distance from 0 that is 4. One is x plus 2 equals positive 4, and the other is x plus 2 equals negative 4. Students want to make that negative. You don't change what's inside the absolute value, you leave it as it is. Alright, now we go about solving these problems individually. So with the first problem I solve, I subtract away the 2's, I get x is equal to 2. The second problem I solve again by subtracting the 2's, and on this one we get x is equal to negative 6. Now I'd like to check. So I'm going to check my values in my original. So I have the absolute value of 2 plus 2. Does that equal 4? Well, 2 and 2 gets me to 4. 4 is 4 away from 0. So this is a solution. X equals 2 is a solution. The next problem. Again, I'm going to check in the original. I have negative 6 plus 2. Does that equal the absolute value of negative 6 plus 2? Does that equal to 4? Again, I'm checking in the original. Negative 6 plus 2, that gets me to negative 4. Negative 4 is 4 away from 0. So again, I get a true statement, and that means that my solutions are negative 6 and 2, because these numbers make this expression have a distance from 0 that's 4. All right, example number 2. I can split because my absolute value is isolated. And again, there's one number that'll there's two numbers that are 15 units away from 0. And again, when I split, I have to drop the absolute value symbols. So I'm going to get 3x plus 6 is equal to 15. And I'm also going to get 3x plus 6 is equal to negative 15. Again, nothing changes from the inside of the absolute value. All right, so let's see here. I subtract my 6. I get 3x equals to 9, divide out the 3. This x is going to be equal to 3. Again, solve using the same steps. Subtract my 6. I owe you 15, I owe you 6, I owe you 21. And I get 3x equals 21, divide away the 3. X is equal to negative 7 because it's a negative divided by a positive. Let's go ahead and check this. So I'm going to again check in the original, the absolute value of 3 times 3 plus 6, is that equal to the length of 15 from 0? Well, 3 and 3 gets me to 9, 9 and 6 gets me to 15. The absolute value of 15 is 15, and we get a true statement. So x equals 3 is a solution to this absolute value equation. Let's do another one, or check the other one. So again, I'm going to plug in for my x, 3 negative 7's plus a 6. Does that have a length from 0 that's 15? Well, this gets me to negative 21 plus 6. I owe you 21, I give you 6. You're going to tell me I still owe you 15. So I have the absolute value, I'm going to put that. I have the absolute value of 15, which is 15, because I have the absolute value of negative 15, which is 15 units from 0. And again, I get another true statement. So my solutions to this absolute value equation are 3 and negative 7. All right, moving on to example number 3. Can I split? No, because the absolute value is not isolated. This 6 is keeping it from being isolated. And to isolate it, I just have to add 6 to both sides. Okay, that cancels out. Now I have the absolute value of x plus 3 is equal to 15. And now I can split. Now I can split. X plus 3 equals 15. And again, notice I'm dropping the absolute value, and I only make that number negative in one of the situations. X plus 3 equals to negative 15. And we're figuring out the value of x that makes it 15 away, and we're figuring out the other value of x that makes it negative 15. Because ultimately, there's going to be two numbers that are 15 units away from 0. And this is how we find it. Okay. I feel if I continue with this, I'm going to be a little bit redundant for that one. That example, I thought it's important to show you the key step. The crickets are back. And let's look at this last one. This last one right here. And by the way, you guys can hopefully finish this problem. All right, last problem. Is my absolute value isolated? Now, students are going to distribute. No, you can't. You got to add that away, divide that away. So let's add away the 3. That cancels out. Now I have 2 absolute values equal to 20. I'm going to divide away this 2. And now I have the absolute value of x plus 4 is equal to 10. Now that I've isolated the absolute value, now I can go about splitting it up. So I'm going to have the absolute value of x plus 4 is equal to 10, go about solving it. And the second one is going to be the absolute value of x plus 4 is equal to negative 10. And again, go about solving it and checking it. So I'm going to check off the second goal. And again, please make sure that you understand to split the absolute values after it's isolated, not before, otherwise we're going to run into problems. So I'm going to go ahead and end this lesson here. Again, I hope everybody is doing all right out there. Have a great day, everybody. Bye-bye.